Hello everyone! Today I will share to you about the intercepts and asymptotes of logarithmic functions. I know you're already familiar with these terms, but I want to reiterate these again so that you won't forget. So we have here the x-intercept. It is the value of x at the point where a line or curve crosses the x-axis. On the other hand, the y-intercept is the value of y at the point where a curve crosses the y-axis. So if the graph crosses the x-axis, that value is the x-intercept. And if that value crosses the y-axis, that value is called the y-intercept. With regards to the asymptote, it is a line which is approached by a curve but never reached. So when a graph has an asymptote, the graph seems to approach closer and closer to that particular line, but it will never reach or cross on that line. Now this time, let us try to find the intercepts and asymptotes of logarithmic functions. Let's start with this first example. To find the x-intercept, replace f of x with 0 and solve for x. So in this case, f of x will be replaced with 0. We need to transform this into its equivalent exponential form. And we all know that the base in a logarithmic form is the base in an exponential form. The logarithm is the exponent. Therefore, it is written this way. So we have this line. Now applying the rules of exponents, 4 raised an exponent of 0 is 1. And then just copy x minus 5. Simplifying, we have 1 plus 5 equals x because we transpose negative 5 to the other side. Now, the value of x is equal to 6. Therefore, this is our x-intercept. At this particular value or at this particular ordered pair, the graph crosses the x-axis. With regards to the y-intercept, we need to evaluate the function at 0. So that means all x's will be replaced with 0. So that is why we have this. And then replacing x with 0, we have 0 minus 5 is negative 5. Take note, the argument of the logarithm is negative. And we know that the logarithm of a negative number is undefined. Therefore, the y-intercept is none. Now for the vertical asymptote, it is obtained by equating the argument of the logarithm to 0. Previously, I have introduced to you where to find the argument of the logarithm, and it is this expression. So x minus 5 equals 0, therefore x equals 5. This is our vertical asymptote. Logarithmic functions have no horizontal asymptote. So that is how to find the x and y intercepts as well as the asymptote of a logarithmic function. Let us try to check and cross-examine it in the graph here using a graphing software. So this is how the graph looks like. And as you can see, this is the x-axis. This is the y-axis. The graph crosses at the x-axis at point 0. So this is our x-intercept. Now as the graph moves downwards, it seems to approach this particular line. This is our vertical asymptote. The line x equals 5. It's just easy, right? So let's move with our second example. To find the x-intercept, we replace f of x with 0 and solve for x. So in this case, do we need to transform this already into an exponential form? Not yet. We need to transpose this expression first, or this term, to the other side. So we have here 1 equals logarithm of quantity x plus 8 to the base 2. And then you can now transform this into an exponential form. So our base is 2. The logarithm, which is the exponent, is 1. So that would be written this way. Now 2 to an exponent of 1 is of course 2. And then we transpose 8 to the other side. We have 2 minus 8. Therefore, x equals negative 6. And this is our x-intercept. For the y-intercept, we again evaluate the function at 0. So replace all x's with 0. 0 plus 8 is actually 8. And then copy first minus 1. Take a note that you don't have to subtract this expression because we need to identify first the logarithm of a to the base 2. And how to do it? So we know that when we transform this expression into its equivalent form, we are actually looking for the value for which, when the base is 2, it will result to 8. So what number would that be? Well, of course, it's 3. That is why we have here 3. And then we proceed with minus 1. Therefore, the y-intercept is 2. In this particular point, the graph crosses the y-axis. So you just have to recall the concepts of the laws of logarithm for you to be able to find the value of what is asked in the statement. Now for the vertical asymptote, equate the argument of the logarithm to 0. So that would be x plus 8 equals 0. Therefore, x equals negative 8. And this is our vertical asymptote, the line x equals negative 8. There is no horizontal asymptote. Comparing it to our graph, so this is what the graph looks like. In the x-axis, the graph crosses at negative 6. So this is our x-intercept. In this line is our vertical asymptote, x equals negative 8. And of course, on the y-axis, the graph crosses at this particular point. So this is our y-intercept. Indeed, what we have solved earlier matched with what is shown in the graph. So let's proceed with our last example. Function given is f of x equals logarithm of x to the base 4. So for our x-intercept, we replace f of x with 0 and solve for x. Now transform this into its equivalent exponential form. So 4 raised an exponent of 0 is, of course, 1. And therefore, the x-intercept is 1. For the y-intercept, we evaluate the function at 0. And since logarithm of 0 to the base 4 is undefined, there is no y-intercept. If you try to check it using your calculator, when you input the logarithm of 0, whatever the base may be, it's an error. It's because it's undefined actually. So there is no y-intercept. For its vertical asymptote, again, the argument of the logarithm cannot be equal to negative. Without even solving, we can determine that its vertical asymptote is at the line x equals 0. We merely equate x to 0. Let's compare it with our graph. This is what the graph looks like. On the x-axis, the graph crosses at this point. Indeed, this is our x-intercept. There is no y-intercept, actually. And this line, the broken line in blue color, is our vertical asymptote at the line x equals 0. And that's how to find the intercepts and asymptotes of logarithmic functions. Good luck and have a great day!